Today I've got a fun little project, and that is to integrate a rear light into the automatic shifter on my bike. Now, someone gave me a broken bicycle light. It's one of those really cheap ones you can get for about £1. I think the battery contacts have broken off the circuit board or something, but anyway, this is the electronics from it. Incredibly simple, but it's one of those ones that has that annoying thing where it has like 7 different flashing modes and you have to click all the way through them to turn it off. But I managed to fix that by connecting it to a microcontroller, so we can get this Arduino to do the button presses for us. So if I put in the serial monitor here, for example, send it a 1, turns it on. If I send it a 7, goes through all the modes and turns off again. So that means I can get the automatic shifter to send out button presses to it, and we can use it as a controlled light that could be either automatic, so if like a brake light for example, it could come on when there's a speed difference, so like if the current speed is less than the previous speed, then it could put the light on, so like a brake light. Or I could have it so I can switch it on using Bluetooth, for example. So I'll go through how you connect it up. So you've got the power supply coming in on this end of the board. Now it's meant to run off 2 AAA cells, so that's around 3 volts. So I put it onto the 3.3 volt pin of the Arduino, and the other one onto ground obviously. It's really a bit at the absolute limits. When the light is on continuously, it's at the absolute limits of what the Arduino can put out. So it really would be better to have, and what I'm going to use is a separate 3.3 volt regulator for it. Or you could put a low value resistor in line. Here that would reduce the brightness a little bit, but bring the current down. Of course, if you're using it in flashing mode, it's not such an issue. And the button here, it basically, the middle contact, it's got 2 each side which I've stripped off just to make it easier to solder. But the button makes contact between this center one and ground, so you can just put this wire to a digital pin on the Arduino. Screwed it into the box, and if it ever fails I'll just scrape it off and start again. Now let's wire it up. There's the 3.3 volt regulator. For some reason I was going to put it onto the 5 volts of the Arduino and changed my mind at the last minute. I think it was the listing that I bought those from said that they are 5 to 3.3 volt regulators, but it's actually a standard chip, so it doesn't matter. It takes higher voltages, so it's coming directly off the battery pack, which means if anything goes wrong with the Arduino, then it will still work. And as you can see, I haven't got the Arduino in there at the moment, and if I use this little jumper wire to ground where the digital pin will be, I can get the light to come on. So next is to do the coding, which opens up all sorts of possibilities for controlling this light. I may actually add a backup button in here somewhere so I can still activate it manually. So let's go and have a look at the code. Quite basic really. To actually do a button press, what you need to do is set a pin as an output, write it low for, I found 30 milliseconds is about the fastest, and then after 30 milliseconds you then put it as an input so that it's basically floating again, and do that for 30 milliseconds, and that's what you call a button press. And then this just reads from the serial, and it just, whatever value you put in, it just presses the button that many times. The Arduino in there has some basic bike light control code on it, and this phone here is connected to the Bluetooth module, and if I send a 1, it will turn the light on. If I keep sending it 1s, it goes through different modes, and if I send it a value equal to the remaining number of modes before it turns off, it will turn off. So I really like the way that the flashing is controlled through its own chip, so it's not going to disrupt the auto shifter code in any way. It's entirely independent, but now I have to integrate the bike light switch code into the auto shifter code, and then we can see if we can experiment with making this light do all sorts of smart things. But that's it for this video. Thank you for watching.